Section 5, a recap and extension to other concepts. Let's wrap it up. This was the code that we created together. You understand all of this, right? In section 3, I made you understand everything, I hope. If you still have any doubts, you can contact me. Now, this was the code that if you want to solve a tower of Hanoi problem of n disks, you have to move from source using auxiliary to target. Then what do? This is the base case in the first 3 lines of the code, in the first 3 lines of the function, which is if n is equal to 1, there's only one disk, then you can move the disk 1 from source to target and you're done. Otherwise, you break down the problem further, which is the recursive case. So for moving n things, okay, you're seeing me reversed. For moving n things from source to target using auxiliary, what do? You move n minus 1 things from source to auxiliary using target. Then you move the nth disk from source to target directly. Now your problem is moving these n minus 1 disks from auxiliary to target. That's it. And when this function happens, it calls itself with smaller input, and then whenever you open these inputs, you get a step-by-step solution of what to do. Alright, I told all of this to you in detail in the 3rd section, so I hope you watched it. If not, please watch it, and don't watch this if you don't have time, but watch that. This is the output tracing. We did this by calling this function with 3, a, b, c. This will be the output that you'll get, and I made you trace all of it. You also have a task like that in the homework or assignment for you. So this is what you have to do. It's a visual representation too. For those of you who cannot watch the lecture again and again, this is like a crisp summary of everything. Then the last section, various recursive concepts to Tower of Hanoi. The first one is understanding the base case. So you know that in the Tower of Hanoi problem, the base case is when there is only one disk. So you move it directly from source destination, like this one, the base case. Then breaking down the problem, the basic of recursion. Recursion is breaking down a bigger problem into smaller, simpler problems, right? For n greater than 1, the problem is broken down into subproblems, because when n is equal to 1, that's the base case. So for n greater than 1, we break down the problem. The algorithm first moves n minus 1 disks from source to auxiliary, then the remaining disk to target, then finally moves n minus 1 disk from auxiliary to target. That's all. That's how we break down the problem. It's just the same Tower of Hanoi problem called again and again with smaller inputs. Recursive call. The function Tower of Hanoi calls itself recursively to solve the smaller subproblems and create even more smaller problems. Okay, like here, this is the original function call. Inside that, there are 2 function calls. So this function will call, this will run, then another function call will happen. Then with this input, this will call again, then this will call again, then this will call again, unless this function call returns. Then the next line is executed, then this function is called. Then this function calls itself numerous times until base case is returned, and then the program ends. Okay, it's the same function with different inputs called again and again. That's what solves the problem. Inductive step. The inductive step involves assuming that the recursive call works for a smaller problem, that we know that moving n minus 1 disks will solve the problem. So we assume that if we just keep doing this again and again and again and again, it will solve the problem, because it's mathematically true, right? We covered everything in this algorithm, right? From n disk to single disk, this should work. So this is called induction, because you had a small simple proof that yeah, this works for this, so it should work for similar bigger inputs too. Backtracking, a very important term. The algorithm moves forward with recursion, making choice to solve smaller subproblems. Okay, you have one recursive function, which is the main Tower of Hanoi, to which you give your inputs. Then it breaks it down into smaller problems, and then those smaller problems generate outputs. Then when all of the outputs are there, you can track back. That's called backtracking. After reaching the base case, it starts backtracking, ensuring that each move is correct. An entire problem is solved correctly. State management. The state of the system or configuration of disk on pegs, which I showed in the diagram, like 3 disks, 0 disk initially, then you move them. It changes with each recursive call. Okay, for each call, You have a different source, a different auxiliary, a different destination, different value of n. I told this to you, okay, in the third lecture. So this is why it's not the same function with the same inputs. It's the same function with different inputs. Optimal substructure. The optimal solution to tower of Hanoi problem is achieved by solving optimal solutions to its subproblems. Fair enough. The solution structure exhibits optimal substructure because for solving the bigger problem, you have subproblems, and those subproblems should be solved optimized in an optimized manner. Okay, so this is a divide and conquer approach. And okay, end of section. So these are the terms that you will use a lot and you will hear a lot in your journey ahead, backtracking, divide and conquer. So this is a little introduction of how Tower of Hanoi and recursion helps you connect these things. Okay, I hope it was useful, and just please watch lecture 3, section 3 lecture, and you learn a lot. And okay, do good in your DAs. If you want, then I can now show you a little bit of your DA questions too and a guide to solve them. I think that would help. Okay, I should solve it. Alright, so here's the explanation of the DA. It's not necessary, but still I just want to help you as much as I can so that you don't cheat and you don't feel clueless. Okay, so first question is CAT 1 exam paper and registration number. This is just an analogous question to Tower of Hanoi, in which instead of Tower of Hanoi there is a robotic system. So instead of manually shifting the packs, there is a robotic system which shifts the papers from one drawer or compartment to other. Alright, it's simple, just like Tower of Hanoi. Pay attention to the order of inputs or parameters. The first one is from, then it's to, then it's aux. Okay, pay attention to it. Then these are simple questions on them. Just write what you feel correct and I'll get it. Just don't cheat and write good answers. Okay, your understanding matters more than the correctness. And see, it's kind of a paradoxical statement, because if you understood then you will answer it correctly, but I get it. Okay, it's not necessary that if the answer is incorrect then you did not study anything or you did not understand anything. There might be cases when you just got confused, but write your answer what you feel is correct and justify it. Okay, that's all I want. That's all we want. Then this is the second question. Very easy. This is the first initial step. Just take the tool. Now what step is it in this picture? You can use that tool and see which step is it, and then draw the diagram of step 6. Instead of drawing the diagram, I might ask you to give a screenshot of step 6, but it will just increase the scope of cheating, so I'm not sure what I'll do. And I might even change it to 4 instead of 3 towers, but let's see. Why is the base case crucial in recursive function? And just some questions about base case and infinite recursion. You can give them, answer them easily, and write in your own words. Yeah, come on, don't ask ChatGPT for it. Then consider this code, what error is present. Very simple question. Watch section 3 of the video and draw a similar tree for Tower of Hanoi 4 ABC. So in, I think, the third section of the section 3 video, in the second section of the section 3 video, I have drawn like a tree. Like this is section, this is the function call, then it calls these two and then prints this statement. This function call calls these two. Like that, there is an entire structure, a tree like structure. I have drawn for 3, you have to draw for 4, and if you feel like it's too much, just draw till 7 function calls and I'll understand that yeah, you got it. That's all. Then there are some common questions that you have to do, and those are very easy. So I hope it's clear, and don't worry, it's easy. Just pay attention and learn. Okay, all right, see ya.